what is AI in 5 minutes. Since then, a lot has changed. So here's a sequel with additional information. The information in the original video is still true, so think of this as part 2. When we last talked about AI, it was getting good at recognizing images, understanding speech, and analyzing data. Today, AI is creating, reasoning, making decisions, and even interacting like a human. Some of the biggest breakthroughs are in generative AI, agentic AI, autonomous AI, and the journey towards AGI or artificial general intelligence. Let's first start with generative AI or ChatGPT kind of models that most of us are familiar with by now. Gen AI has gone beyond just analyzing data to producing new content from scratch. Gen AI is built on large language models like GPT to predict words by analyzing massive amounts of text and learning their probabilities of occurring close together. They use deep neural networks, specifically something called transformer architectures, which are a type of neural network designed to handle sequential data efficiently. Transformers improve upon traditional neural networks by using self-attention mechanisms, allowing the model to weigh the importance of different words in a sentence and understand the context over large or long passages of text. Diffusion models create images by starting with some random noise and refining it step by step. They work by gradually reversing a process that initially adds noise to an image, training the model to reconstruct the original image from the noisy version. This is achieved through deep learning networks, typically using something called U-net architectures, which learn to predict and remove noise at each step, ultimately generating high-quality, realistic images. Multimodal AI integrates text, images, and audio, allowing AI to understand and generate content in multiple formats. It achieves this by using specialized transformer-based models called multimodal transformer model that can process and align different types of data within a shared representation space. As you know from my previous machine learning videos, AI's main way to understand the world is to map concepts in some representation space. This is often a vector space. In here, by learning relationships between the modalities, multimodal AI can perform tasks like describing images in text, generating images from text prompts, or even creating videos with synchronized audio and captions. And then there's agentic AI. Traditional AI follows instructions, but agentic AI makes decisions and executes tasks independently. It uses memory, planning, and reinforcement learning to execute tasks without human intervention. It does so by breaking down complex goals into smaller steps, adapting when things go wrong, and continuously improving. One of the common use cases for agentic AI is that it integrates LLMs with external tools like databases, APIs, and reasoning frameworks. This allows AI agents to go beyond simple text generation and interact dynamically with external systems, retrieving real-time information, performing calculations, and executing automated tasks. For example, when a customer asks, "Where's my order?" instead of just providing a generic text-generated response, the AI can query the order database to retrieve real-time status, call the shipping API to get the latest tracking update, analyze previous customer interactions to offer proactive support like offering a discount if the order is delayed, and automatically send an update to the customer, reducing the need for human intervention. Agentic AI relies on deep learning for perception and language understanding, but also integrates with symbolic reasoning, memory, and goal-oriented planning, which go beyond deep learning. The AI we just discussed was all digital, but now AI can interact in the physical world as well. For example, robotic AI combines sensors, reinforcement learning, and computer vision to navigate real-world environments. We know about self-driving cars navigating the roads. They use sensor fusion, which is a combination perhaps of LiDAR, radar, and cameras, plus neural networks to detect objects and predict motion. Technology-wise, this type of AI uses deep learning, control systems, reinforcement learning, and symbolic reasoning. And then there's the end game, which is artificial general intelligence, or AGI. Right now, AI is still narrow. It can master one task at a time. The dream of AGI is where AI can think, learn, and reason like a human. How would that work? Instead of just predicting outcomes, it would use causal reasoning to understand why things happen. It would use few-shot learning to learn from a few examples just like humans, unlike today's AI, which requires a huge data set. Here are some optimistic examples and predictions of how the future would be shaped by AI. Personalized assistance. AI assistants are evolving to predict what you need before you even ask, from scheduling meetings to reminding you about daily tasks. Over time, they learn your habits, preferences, and routines, making life smoother and more efficient. AI-human collaboration. AI acts as a powerful tool that helps humans think faster and work smarter, whether in business, art, or science. Instead of replacing jobs, it automates repetitive tasks and provides insights, allowing people to focus on creativity and complex decision-making. AI for science and medicine. Instead of slow trial-and-error testing, AI can analyze millions of potential drug compounds in a fraction of the time. This accelerates the discovery of new treatments, helping researchers find cures for diseases faster and more efficiently. With all this going on, how can you stay ahead? The best thing you can do is to continue learning how AI works, experiment with tools, and stay informed. AI can help you work smarter. AI literacy is as important as digital